Hi, my name is Ryan McGarry, and this is my portfolio walkthrough. I'm going to dive into two studies of mine in just a second. And for my quick background, I hold a PhD in human factors from George Mason University, and right now I'm leading a UX research team at Google. Before that, I was the vice president of research at Spark Neuro, and I grew the company from 3 to 49 employees, ran cross functional teams, and owned client relationships. And in addition to that, I helped close our Series A. So that mix of scaling, strategy, and hands on research is what I bring to the table. And a lot of that work is actually what shaped my experience and the two studies that I'm going to be talking about here. So let's jump into the first study. For this first study, it's titled Usability Testing of Inline Code Review Layouts. And this was done for a client that I actually can't name for confidentiality reasons. And even though it's a confidential client and it was doing internal software testing, which means I can't share direct screenshots or videos from that study. The software that I tested was a modified version of Microsoft VS Code. So I was able to take screenshots of the same types of layouts that I tested from VS Code, since that's publicly available. And so for this study, this was done on internal code review software, again, a modified version of Microsoft VS Code. And this software is used for editing and doing code review by software developers. And the goal of the study was to test out and compare users' preferences between different options that the team wanted to potentially use as the default version for a new update they were going to make to the software when users were doing internal code reviews. And so I was the lead UX researcher on this study, and I conducted an A/B test where participants were tested remotely, and this involved usability testing as well as a think aloud portion of the study as the protocol. I tested 6 participants who were internal software developers at the company, and the study took about 3 weeks to complete. And so the problem here that precipitated the study is that there was an internal team that was working on designs for what would become the new default view for the inline code review portion of the software. And this is software that's used by about 80 to 90,000 software developers. So this is both good and bad. It would have a very large impact on the company. And so they needed to understand which design options the users would prefer before they were to launch this large software update. And they would base the default UI for the code review from the findings of this research. And so the user feedback we collected allowed the team to know which UI view should actually be presented to users by default. And then some other problems or goals here in the study were that they wanted to uncover any other points of friction with this process, and then to discover or hear from users whether there were any new features that they desired and wanted to be included in the software update. So overall, this would help enhance the usability of the code review process. So my role in this study was to lead the execution of the study from start to finish. First, I held a kickoff with the cross-functional stakeholders, including designers on the team, software engineers, and a product manager. And in that meeting, the goal was to understand what they wanted to learn from this study, what their research goals were, and their main questions. In addition, I also asked about the work that led up to this study and basically precipitated their need to run this study. So what was the background or context that led to them developing these research questions? So After the kickoff meeting, that's when I began the recruitment process, where participants were recruited for the remotely moderated sessions that I conducted. And this was done on 6 internal participants who were software developers with mixed levels of tenure. Some were newer software developers who had been at the company for up to 6 months, and then others had been at the company for a range of 2 to 5+ years. And these remote sessions lasted about 45 minutes each. And in these sessions, first I asked participants to tell me about their background and also their experience using the software and any existing issues or pain points they had, as well as aspects of the software that they liked. Then I gave them a link so that they would be able to open up this unreleased alpha version of the software, and the link would either have them test out the layout version A first or version B first. So this was done in a randomized order. Half the participants saw version A first and then version B. The other half saw version B first. And when they were taken to the first screen, I asked them to think aloud and take a look at what they saw, giving their initial impressions, anything that jumped out at them, and anything that was unclear or confusing with the interface. So they went through this process, and I gave them then a task or a series of tasks to complete, and asked them to think aloud as they were going through the task, where they essentially opened up a code file that they had selected for the study. They reviewed code changes that were being made, and these were code changes done by one of their peers or colleagues. They had to reconcile the differences, accepting or rejecting code changes, and then submitting the final version of that file. And during the sessions, I was able to take notes, record the audio and video while participants were sharing their screens, so I could go back later and refer to these notes and recordings. And I also live streamed the sessions for the stakeholders to observe and take notes. There was an active chat space. And in addition to that, they were able to hear the direct feedback from participants. So from this, I analyzed the findings and wrote up a summary of what we heard from participants in a slide deck. So I presented this report to the internal stakeholder team. And then after the study, I collaborated or continued to collaborate with the designers, product manager, and and software engineers so that we could decide on the most important feature changes to make. We went through the development process, and I worked with the designers so that we could launch on target, on time. And then after this study, I actually conducted some follow-up user feedback research in the form of a survey, asking people what they thought about the newly launched version compared to previous survey data that they had collected to identify if they actually liked the changes and how people felt about this latest version compared to the one before that. But before getting into that, I wanted to show you 2 screenshots. So again, these are from Microsoft VS Code. They're similar to what was tested in the study that I'm describing here for you. And version A was a side-by-side layout where there were 2 different versions of the code file, and then the user could click on those to accept or reject the changes. Version B had a stacked layout of the 2 different code files, and so the key findings that came up in the study were that people overall preferred version A, the side-by-side view that's shown here. This was because it was significantly faster for them to complete the task, and they said that it was actually easier or more readable for them as they were scanning the differences in the code file from left to right along the same line. This reduced the amount of scrolling they actually had to do, and so this made it easier and also just simply more intuitive for them to go through this process. And they definitely did not like version B as much, where the two code files were stacked. They said that it was less readable and there was just more friction with the process of going through and identifying and deciding to accept or reject the code changes line by line. It took them much longer to go through this. However, one thing that they noted was that they would still like to have the ability to select the default view. Uh, this was not something that was presented to them as an option, but during the semi-structured interview portion of the study, where we asked which version they preferred more and why, and then if there were any other features they would like to have made available to them, two of the users said that even though they preferred version A, they would still like to be able to select the default view. The reason was that it was easier to see the code side by side and to make that and to go through that task. However, it would be helpful if they're using a laptop while traveling to be able to switch to the other view, which they said would be easier for them with that screen, as opposed to their typical larger monitor where they have more screen space. So there were certain cases in which they felt it would be better to be able to select version B if they were using a smaller screen. So for the study, we were able to deliver clear, actionable recommendations based on what we heard from the participants that shaped the actual final default view that was launched internally. And the team was able to introduce a couple new features, including selecting the default view and some other changes that improved the user satisfaction when I did that follow-up testing on the newly launched software update. And we were also able to help prevent bugs with this alpha version by having the engineers watch along with the stakeholders live. So when some bugs or glitches came up, essentially unexpected behavior with this software, they were able to help troubleshoot on the fly. And then we were able to get good quality feedback in all of the sessions. And again, the new version was launched internally to over 80,000 employees or users. So this was able to make or have a big impact on the company. And we were very pleased with the product roadmap and the timelines for the deliverable. So the study basically enabled the quick data-driven decisions for the stakeholders that allowed us to have this rapid deployment for the better code review user interface. The second study I'd like to talk to you today about is one that was conducted for our stakeholder or customer Tesla when they first came out with the autopilot feature in their Model S. So I was the lead researcher on this study while I was at Spark Neuro, and we tested out or compared the Tesla Model S P90D. This was the fastest model they had at the time in 2016, and this was just when they had newly launched the autopilot feature, and we compared this Tesla to the base model Honda Civic. This was the newest Honda Civic model at the time. And the goal of the study is our client wanted to understand how people using this self-driving technology for the first time experienced it. They wanted to understand what their overall reactions were, and also their levels of cognitive attention, their emotional responses while driving the car, both with autopilot on and then with the feature turned off for a baseline experience in the Tesla. They wanted to understand user trust in the system when they were actually driving it on open roads, or public roads, that is. And then they also wanted to understand how long people would stay focused on the road when they activated this feature, because there might be differences in people's honesty when they're asked whether they would keep their attention on the road after turning this feature on, or people might not be able to understand or have enough introspection to say if they would really trust it or not. So they wanted to get actual real world measurements of how well people were able to keep their attention focused on the road, both with autopilot on and off, so they could see if people trusted the system and if they kept their attention focused, or if they started to engage in distracted, dangerous driving behaviors when the car was driving itself. So for this study, we conducted one-on-one real-world test drives where participants drove either the Tesla or Honda. So this was a between subjects design. And we connected them to a remote EEG headset that measured their brain activity, and then a GSR wristband. So that stands for galvanic skin response. So that's the wristband that you can see in this picture here. It's a white wristband that measures the autonomic nervous system response, heart rate, and heart rate variability. So the levels of excitement based on these measures. And this is also wireless. Then the third device is a pair of Tobii eye tracking glasses. It's not pictured here, but it's seen later in the presentation. And then in addition to these measures, I conducted semi-structured interviews. And I say I because I was running some of the testing, but I also had other researchers who were helping me while I was the lead researcher on the study. And then you can see me there hooking up one of the participants. So we tested 10 people in the study. They were recruited with a professional recruiter from the greater DMV area. The testing took place in Bethesda, Maryland, where our office was located, and the study took about 6 weeks to complete. So in the study, the outcome was that we actually found some unexpected results or insights on potentially dangerous driving behaviors with automation systems while people were using the autopilot feature in the Tesla. So after conducting the study, the Washington Post was interested in doing a piece on this, so they wrote up an article and did a video that's linked here. So you'll be able to either Google this or use the link that's embedded in the PowerPoint slides. But basically, people reported initially that before they got in the car and we turned on the autopilot system, they reported that they would still keep their attention on the road and they didn't feel like they would be able to trust this when using it for the first time. However, when participants were actually put in the driver's seat and they turned this feature on, people were able to disengage from the road and feel comfortable even taking out their phones within about 60 seconds of activating it. So this was pretty surprising. This was not in line with our main hypothesis in the study. And it was also a pretty useful finding because it showed that people couldn't feel comfortable engaging in dangerous driving behaviors, even though they initially said they wouldn't. So the challenge here is that autonomous driving is something that can be a very useful feature. However, it raises a lot of serious concerns around trust, safety, attention, and if used improperly or in an unsafe manner, can put people's lives at risk. And this was something that was commercially available in self-driving systems for the first time. This was brand new. And so the big challenge or problem here is that there were a lot of questions about drivers' ability to remain focused on the road when engaging autopilot, even though it was new and tested in safety studies. This was something that was being launched to the public on a grand scale for the first time. And so it's important that drivers actually have to feel confident when handing over control to the car without actually becoming distracted. And it's important that a product is released to the public that can be used in a safe manner and we can trust other people, because even if people trust it, there are instances where it might not perform as expected and it can have problems or not behave in a safe way, the way a human driver might drive the car. And so we needed to measure not just what people said they would do, keeping their attention on the road, but what their brains actually did when using autopilot. So the objective in the study was really to identify friction points in the driver's experience and to find out if there were opportunities to design something that could be a little more intuitive or easy to use when activating these features like autopilot, self-parking, and then other features in the control panel in the Tesla. For this study, I led and executed the research end to end. So initially, I had a stakeholder kickoff meeting. So this was with project managers and then also engineers. And in the meeting, similar to the first study I described, the goal was to describe or hear about the background that led to this study so I could have more context for the stakeholders to tell us more about the research questions they had in mind, their hypotheses, and also the methodology that they would like us to use. And then I worked with the team to design the complete methodology and trained the other researchers at our company so that they would be able to help with testing participants and also data analysis for the study. We used a professional recruiter to find participants and get them scheduled. And then I helped coordinate the logistics for testing that was done in the DMV area, so DC, Maryland, and Virginia. And so I was the one who led designing the final protocol and also laid out the test drive routes. And we were careful with selecting the routes so that this could basically be used to have a complete mixture of experiences for the drivers, so that way they would have different situations they would encounter. A range of low and high speed roads, for example, highways, city streets, and also less congested areas. And there you can see a picture of the Washington Post writer in the passenger seat, and he's wearing the Tobii glasses here. So those record where the wearer is actually looking, and then they also record what they're seeing and the audio. So we conducted the test sessions while recording data real time and seeing the output on the test laptop from their neural activity or EEG. So we could see a graph of attention on a scale of 1 to 10, the emotional response, and also their eye tracking data live. And the study lasted about 6 weeks. We analyzed the qualitative interview responses along with the neurophysiological and biometric data. So that's the brain data and then also the GSR sensor data, together giving us a clear and complete picture of attention and emotional responses while people were driving the Tesla or Honda Civic. And then we synthesized and analyzed the findings to be put into a complete final slide deck report that I presented to the stakeholders at Tesla, and then also presented to the Washington Post with the CEO of my company at the time, Spencer Gerald. He's also the CEO now. And after completing testing and delivering the results, there were some key findings and real impact from the study. So first, participants claimed before getting in the driver's seat that they felt they would stay attentive to the road while driving, and with the autopilot feature being turned on for the first time. However, once people actually started driving the Tesla and they activated the self-driving mode, their brain data from the EEG actually showed that cognitive attention dropped off very quickly within an average of 60 seconds across all participants, and for some people within about 10 seconds their levels of cognitive attention immediately dropped off. They were able to feel relaxed, which was a good thing in a way, but it's not good that they felt comfortable not having to monitor the autopilot system. And then after that, it didn't take long for several participants to actually take out their phones or start doing other things. And this was in a car that costed about 135,000 US dollars MSRP at the time. Also, as part of the test, participants were instructed to hit the accelerator pedal, and we measured their emotional responses to that compared to people doing the same thing while driving the Honda Civic, a base model which did not have nearly the same level of acceleration. So the Tesla Model S P90D had a 0 to 60 time of 2.8 seconds back in 2016. Since then, the newer models have been able to achieve faster speeds. So when people hit the gas pedal in the Tesla, we not surprisingly saw very quick, sharp increases in positive emotions such as excitement and engagement. And with the Honda Civic, when people were told to hit the gas pedal, the responses were pretty lackluster. We weren't able to find any significant increases in positive emotions. And so the Tesla was able to spark real positive levels of excitement. Then, when participants, as part of the test, were instructed in the Tesla to activate the self-parking feature in a parking lot, we encountered several situations where the feature wasn't working properly. Again, this was new software at the time, so there were several bugs that we found, and that ended up revealing levels of higher stress and attention, which reflected a negative emotional response. And when we conducted follow-up interviews with these participants asking about this event and what they felt when the self-parking feature didn't work, they said that it was actually pretty frustrating because they had to try pressing the button on the display in the Tesla multiple times, and this still didn't work. So in the study, the findings essentially showed that there were potentially dangerous driving behaviors with this new self-driving feature, and this is something that has to be worked on more so that designers and the project managers can do a good job of helping to essentially design a system in a better way so that people can drive these cars more safely, and there are better driver monitoring systems in place as well as warnings. And the recommendations that we made to the Tesla team, and then also the findings that ended up being published in the Washington Post, were able to help impact thousands of customers because they were able to use these findings from the study in future software updates. It wasn't something that they needed to put into a physical product and wait until they came out with a new car. So they were able to make over-the-air software updates with some of our findings in mind. And then because this was able to gain a lot of public visibility in the Washington Post, this potentially had the ability to influence other auto companies' decisions as they wanted to start working on the same features. And I say that hopefully because I personally don't know if they did that. Nobody reached out to me or others at my company at the time about this, but I would like to think that it had a positive impact on the industry, even if just a little bit. So there were several key takeaways from a design perspective here, lessons that apply to how we can hopefully build safer, trust-driven experiences. No pun intended with trust-driven. So one is just that attention is something that's fragile and easily broken in a way. So we can quickly become distracted, even if we realize that we can be in a somewhat dangerous situation and we want to stay focused on our goal or our target. It's easy for us to focus on something that's not the main task at hand, even when we realize that it could mean that we're putting our trust and reliance on a system that might not be as well developed as we might hope, or we're putting too much reliance on it, even if it's still a pretty good system. If you watch the video in the Washington Post article that's linked in this PowerPoint slide, you'll see that when the self-driving system was activated, the driver put on the right turn indicator so the car would turn into the right lane or change lanes, and there was a pickup truck in the right lane that didn't want to let us in. And so we were looking at the side view mirror, watching that truck, and it was several car lengths behind us, and he was accelerating fast. And you could see in the video recording that's on the Washington Post website that the Tesla started to change lanes, even though this pickup truck was accelerating in the other lane behind us. And so I actually had to yell to the driver to manually take over control and jerk the steering wheel to turn left to get out of the path of that pickup truck that would have potentially hit us if we didn't change lanes. So the car didn't see that there was a vehicle in the lane that we wanted to change into several lengths behind us, but our driver did. Everybody in the car did. There were 4 of us in the car at the time, and most drivers would have. So it showed that even though this was a small sample size, there are situations where a human driver would still see risky scenarios that this new self-driving system could not identify. And so if someone had put their full reliance on this system and they weren't monitoring it, then that could have led to a collision while I was in the car. Another key takeaway here is that emotional design really matters. So pressing the accelerator, even though it's a quiet electric vehicle, still elicits a very strong positive emotional reaction that we saw in participants from their neurophysiological data live while they were driving. So even though there wasn't a loud engine revving, pressing on the accelerator, allowed the car to take off really quickly. That gave a very nice, positive, visceral response. And those negative spikes that we saw in the data when they would press the button for self-parking and then it wouldn't work also quickly eroded their confidence. We saw immediate negative reactions in the data when something didn't work as expected. And it only took one or two instances for something not working to reveal those negative emotional responses. So it's important that these features work correctly when they're launched. And also, people can try to self-report that they are going to actually monitor the road when they're using self-driving, but it's something that still requires a good scientific approach to measure without just trusting people to say how they will probably use a system safely. And so these principles from this study basically guide how I approach real conversion-driven, high-trust platforms in research today. Thank you for listening to my overview of these two studies that I ran. And you have my contact information if you have further questions. I'm always happy to have a conversation or dive more into this research. Thank you.